This conference will now be recorded.
Now think about control flow like a decision-making center. Okay, this is where you make decisions. Okay, now typically your program is a much complex system. Okay, let's see how a traditional website might look like. Now give me an overview. Okay, what happens in a website? Let's say banking website. What is the first thing you do?
Open.
Okay.
The web page.
Your website browser. Okay. What next?
Put the login.
You log in. And what happens in the login process?
You put the username or password.
You compare user ID.
Yes, with the login.
So this comparison is typically based on your profile, right? Like you have a user ID password set up when you register, and every time you log in, you have to enter the same user ID password. So what these websites do is they compare your user ID and password, and then what is the comparison output here? When you compare user ID password, what is the typical output of that?
Whatever we registered in.
Okay, you tell me now in data type version. Okay, Java data type version. I compare user ID, login user ID, and your registered user ID. I compare your login password and registered password. What is the output when you compare? Data type. Yes. What was that?
Boolean.
Boolean. Okay. When you log in, you typically end up with either true or false. Okay. Whatever user ID password you entered, it either matches your registered user ID password or it doesn't. So anytime you say compare, isn't that a true or false? Yes. It matched. No, it didn't. Okay. Now here, don't you branch in two different flows here? If it is true, you go to a welcome page, isn't it? You go to welcome page. What happens if your condition fails?
Error page.
Then you go to error page. Okay, you try to ask customer to check the user ID password and try again. Okay, now this is what we call control flows. Okay, your program, your software branches out in different directions. Okay, you launch your software, website, whatever, you log in, they challenge you to log in. After you enter your credentials, they compare. When they compare, the result is usually true or false. So you end up in either one of the scenarios, or error page or welcome page. These are all what we call control flows. Decision making tree. Okay, you're making decisions based on what actions they did. Okay, what is the activity throughout the flow. Now, once you're in welcome page, what are the options you get? What can you do? Okay, so in banking, let's say you have okay, in the ATM software, don't you get an option? Press 1 for withdraw, 2 for deposit. Okay, now does this branch out in two flows again?
Yes.
Okay, here we branch out in two flows for withdraw and deposit. What happens in the withdraw flow? What do they ask you first?
The amount you want to withdraw.
Now, what is the decision-making logic you have in the withdraw flow?
The PIN number?
You're already past the PIN number. Your authentication is done, isn't it?
Enough balance.
Yes. What do you compare here?
Balance.
Balance and
Withdrawal amount.
withdraw amount. Now, what is the output of this step?
If we withdraw a boolean, true or false.
Yes, it's true or false. Okay. Now, if it is false, what would be your software's reaction?
Not enough balance.
Error. Okay. What is your software's reaction when it is true? You have enough balance.
He spends money.
Okay. Now, on the deposit side, what do?
Deposit amount.
And is there any checks or a simple?
Or cash.
Yeah. Okay, when you want to deposit, it's a matter of just adding what?
Cash.
So what do you add it on?
It will give you ask the option to add in saving or current.
Correct. And that's when, after you're done, this is when you terminate. Let's see the termination point. Give cash, terminate. Insufficient fund, error message, terminate. Now this is what we call control flow. So at a very first glance, you can entirely visualize your software, what are the various flows or branch you will end up on based on all the customer activity. Okay, your flow starts like this. You go here, they'll challenge you either by PIN or by user ID password. From here, you branch out to one of the flows. Okay, either false, error page, true, welcome page. From here, you branch out again to withdraw or deposit. In the deposit flow, they'll ask you to deposit amount. You enter that, it adds up. In the withdraw flow, you compare the customer's balance. And if you have enough balance, they'll give you cash. If you don't, they'll give you error message. And finally, your transaction ends. So does this look like a branch, a tree branch? Yes?
Yes.
So this is what we call control flow. You start from origin point, start. You go here, you compare, you can branch out in false or welcome page. Here they give you options, withdraw or deposit. And then withdraw, you again have options to compare. Now all the while, you have been relying on operators, isn't it? What operator from the ones we learned are used here? What operators?
Logical upper.
Logical.
Logical and
Or?
Rational.
relational operator. Okay.
Yes.
You would compare login user ID. If login user ID is equal to register user ID, right? And login password is equal to register password. Aren't you using both the operators here? Compare login user ID with your register user ID and login password with registered password. Aren't you using two operators here?
Yes.
How about here?
The same.
Which operator are we using?
The logical and the relational. Oh, what are you asking?
Chosen option is equal to 1. Chosen option is equal to 2. If chosen option is equal to 2, you branch out to the deposit section. If the chosen option is equal to 1, you branch out to the withdraw section. Okay. On the ATM software, what do they do? Press 1 for withdraw, 2 for deposit, 3 for balance.
Oh, yes.
So based on what option you chose 1 or 2, your code will branch into either this section or this section. So here in this branching, what is the operators that we are relying on?
Yeah, relational.
Relational. Anything else? That's it. Okay, here we are checking balance is equal to withdraw amount.
Withdraw amount.
We are relying on relational operator here.
Yes, ma'am.
Okay, and finally you terminate here. So all the while your entire program has different sections of the code. Okay, and you choose what to be executed based on customers interaction. Okay, this is what we call control flow. Okay, you're controlling the flow, isn't it? Based on what happens, what is the customer, how customer is using your system. Based on various decision that customer made, you choose what flow you want to go in. Do you want to show error message, insufficient fund message, give them cash, let them deposit, go to withdraw? This is your entire software's overview. Okay, this is your flow, this is your application flow. Now when you write a program, okay, when you write a method, let's say you have a method called ATM. Okay, in your ATM method, you actually write only certain part of the code or everything?
Certain parts.
So does that mean your ATM will only work for, let's say, deposit? Your ATM does not work for withdraw?
It will.
Works for both.
It will. So you basically write the code for entire ATM software, but you choose what part of the code is required to be executed and what shouldn't be. Okay, based on how the customer is using your website, your software. Okay, so you prepare for every scenarios upfront. You write the code for every scenario. But if I'm a user and all I want is to deposit amount, what section of the code will be executed? Starting from here, this part, then I take a detour here, I come this flow, and then I come here and follow this part. So if I'm a user, am I tracing all your flows or just a section of the flow?
Okay, what do you?
Okay,
Can
as
you
a
repeat?
user,
Mm-hmm.
you typically end up using just a section of the flow. But that doesn't mean your software is only designed for deposit. It's also designed for withdraw, error login, insufficient fund. Okay, so your program should be clever enough to allow customer to take whatever path they choose. Okay, this is possible with control flows. Okay, so this is your entire control flow diagram. Okay, this is your flow diagram for the ATM software. Okay, this is the decision making tree. You have to write the code for everything, and based on what happens, what customer is choosing all the while they are using the software, your different section of the code will be executed. Okay, now let's see how we can do that. Now, program requires to decide if a block of code is to be executed or not. Okay, the control flow provides conditional decision making criteria to allow execution of block of statements. So here, going back to our example, we have several lines of code that is eligible for execution if the login is true. Okay, if your login fails, if the customer using your software ends up in this section, do you want them to operate on these features? If their authentication fails, do you want them to go on this section of the block code?
No.
No.
No, you don't want, right?
No.
If the customer did not successfully authenticate or log in, do you want them to withdraw or deposit?
No.
So
You don't. So your program is made of all this code, but sometimes you have to make decisions. Okay, you want to keep this part of the code away, not accessible, not eligible if the customer goes to this section. Okay, imagine if this is all your program. Okay, in your program you wrote the code for everything: login, error, welcome, withdraw, deposit, insufficient fund. You wrote the code for everything, but here you should somehow block customer from going to this part of the code if their login fails. Okay, so this is what control flow allows you to do. You can choose what block of the program is allowed for execution and what isn't. Okay, that's what control flow does. Okay, it will allow you to group certain lines of code together so the other section will not be accessible immediately. Okay, so let's take a simple example and look at it. The first option you have in control flow is if else. Okay, if else, if else, if else. Okay, we'll go through everything. Now this if section is for executing certain block if the condition satisfies. Okay, now the condition, all the control flows, if else, if and all, they rely on a Boolean attribute. Now you might have noticed this already. Which one of these scenarios are like a either or scenario?
Either.
first one.
Either it is true or it is false. Either it is true or it is false. Here you might have more options. This is not an either or scenario, right? Because there are more than two options. Either or works for what option? Two
Lots.
options.
Two
Okay.
options.
Either or, as the name goes, either you do this or that. Okay, that only applies for two options. If you have more than two options, this might not suffice your either or scenario. Okay. Now, the if loop, the if block operates on certain condition, okay, which usually is either satisfied or it isn't. Okay. When I say it's satisfied or isn't, what data type does it fit well? Condition is satisfied or condition is not satisfied?
Boolean.
A Boolean. Okay. So this is how you operate on the if loop. If what you have here is a Boolean. Okay. So did this condition satisfy or not?
Yes.
True means, okay, true means yes. It did print hello, right? Now, if this condition doesn't satisfy, meaning false, will it print hello?
No.
No.
It didn't. Okay. So this is a block of code that you want to execute only if some condition is satisfied. Okay, I will print hello, hi. Okay, I have certain lines of code here. Okay, I will print hello. I will add the number A and B and I will print it. Now these lines of code will only execute if the condition is satisfied. In this case, will it print 50 and hello?
No.
It doesn't. Okay, it doesn't print anything because the condition is not
False.
satisfied. If you do true,
Then it's gonna pass.
print hello and it prints the addition of A and B. Now this is the block. Okay, this is what we call the if block. We know that curly bracket is always block, right? Now what block is this? What block is this?
It's a method.
Method block. Main method block.
Okay, it's the main method block.
Mhm.
This is
Block.
This
Class
main.
class level block. Okay, it's a class block. This is a method block. Okay, so what is this block?
Block.
conditional.
This is
Block.
if block. Okay, and the
Information
class
breaking.
block, whatever you see, similarly, this is more like the if block. Okay. All right. So if the condition satisfies, the entire if block will be executed. If the condition doesn't satisfy, this block will be
Not executed.
not executed. So similarly, going back to our software, ATM software, now can you control which block of the code can be executed and which isn't?
Mm-hmm.
Yes.
Right? This is how you do it. You write bunch of code. Okay, you write all the code here for deposit, okay, withdraw, insufficient fund. You write all the code that you have here. If the condition satisfies, if the login is true, everything will be here. Okay. If it doesn't, then we'll have another block where we'll write error message, the login error message. Now our program is designed or equipped to provide all the flows. Okay, we give all the flows, deposit, withdraw, error message, everything is put together. But based on what condition is satisfied, we will block or we will prohibit customer from going in this restricted area. Okay, this is a restricted area. If you enter, you can enter here only if the condition is satisfied. If the condition is not satisfied, this restricted block will not be accessible. Just like here, this is a condition. You have to log in, you have to authenticate yourself. If you are successfully authenticated, then you have access to the restricted block. Okay, if you are allowed, if you satisfy this condition, user ID password comparison, only then you have access to the restricted block, or else you end up on the error block. You won't be able to withdraw or deposit until you authenticate yourself. Okay, that's what conditional control flow is. You can restrict certain part of the code based on a condition, which typically is a true or false scenario. Okay, now in the login, okay, let me write a realistic example. Now, this is where your software launches, the main method, isn't it?
Yes.
Now, when you registered, your user ID password was John and John. John1, exclamation, and John. When someone is trying to access your account, they enter the wrong user ID password. So which block of the code do you want them to end on?
Else.
This one. But is this code equipped to do that?
Yes.
Okay, look carefully. From the main method, which method are we calling?
The bank ATM.
The bank ATM method is what we are calling. The main method is calling bank. Okay. Now bank ATM takes two parameters. What is the data type of these parameters?
String.
String type.
So from the main method, what data type are we passing?
String.
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 And Jane, both are in double quotes. Okay, we are passing string. It takes string. Okay. Now the value of login UID will be what?
John.
Jane. And the
No.
value of login PWD will be?
In one.
Jane. Okay. Now, are you comparing that
Oh,
with the registered user ID password anywhere in your method?
no.
So remember the operators. What do you want me to compare here?
Login user
User
ID
ID.
is comparing register user ID.
Okay, give me the operators. What
Compare.
operators?
Equal.
Double equal
Very good.
registered user ID.
Yes. And what
Comma.
next?
Oh, you wanna put and
And
Which
and
operator is that?
logical.
Yes.
Login password is comparing registered password.
Okay, so now you see the login UID, register UID, login password, registered password. If they match, what do you print?
Welcome.
welcome.
Print welcome. If they don't match,
Login
Login.
error.
now this message is only accessible if this condition satisfies, isn't it?
Yes.
Yes.
If this condition doesn't satisfy, where do you go?
Else.
Else.
Don't you skip all this?
Yes.
This is the exact replica or implementation of our design. Okay, this is our design. This is the design we came up with. The software launches from the main method. Challenge them. Compare their user ID password with your registered user ID password. If this condition is satisfied, you welcome them. If it is not satisfied, you go to error message. Now we write the code like this. If you write like this, what will happen?
Print login error. Oh,
Welcome error message. Are you restricting any blocks here?
no.
Okay, without the control flows, I'm telling you what you might be getting into. Customer user ID password is John and the user entered Jane. So shouldn't that be a problem?
Yes.
Welcome the
You have to
customer even
give
though
a
their credentials were wrong. Okay, all your program has been executed. All the lines are being executed no matter what customer enters. Customer enters Jane or John or anything else. You're not restricting from which line should be executed and which should be blocked. You're not restricting them. Without the control flows, this is what you get into. With the control flows, however, you can block certain code as you wish. Login error. This time, did it print welcome?
nope.
So did we restrict this block based on a condition?
Yes.
Okay.
Welcome.
Did you go to welcome? Did we skip the error block this time?
Yes.
So you see how the control flows are handy when you're making decisions, just like what you did here. Okay, this is just an overview design. You decide how your program software should behave, and based on this design, this diagram, you write your code. Okay, we actually did this part. Compare user ID password and the error page. Did we complete this part?
Yes.
Right, this is what we did here. Compare user ID password and either show them welcome or error. Okay, now let's deep dive into control flows. Now here, typically you need a Boolean, right? So do you remember which expressions gives you Boolean? What are the operators whose output is a Boolean?
And then all
Logical.
Okay, you have logical operators whose output is Boolean.
Mm-hmm.
What else?
Relational.
Equality, relational, right? Okay, all these operators, don't they give you Boolean as the output?
Yes.
Okay. Apply each one of them. Take the relational. A is greater than B. Is the output of this expression Boolean?
Yes.
yes.
And what does the if require? A Boolean. Okay. If require you to write a Boolean. Okay. Now hold. Now be. Okay. Just focus here for a minute. There is no point in writing a value like this. Why? If you write a program like this, what is the problem?
It's always true.
Yes. If you write a software like this, this will always be true, isn't it? It's not going to change on different people. Take the other example. If I write true, what was the problem here?
It will
If
Needs
I
a
enter
co-
True
it needs a
conditional
triple
applied.
right, if I enter John and John, the correct user ID password, you will end up here anyway. If I write the wrong user ID password, where do you go?
else.
Look at the code and tell me.
Still it
Welcome.
will go same.
again to if.
This is always true.
Oh
No
yeah,
matter what
true.
user ID password you enter, this is always true. You'll always end up here, don't you?
Yes.
Okay, are you guys following what exactly the problem is? If you have a real hard-coded value like this, why should we rely on operators?
Yes, that makes sense.
If your program is written like this, anyone who uses your software, they will always go to the welcome section. They will never go to the error page, no matter their user ID password is correct or not, because your code is set to be true all the time. Okay, so you cannot write even see, if requires you a condition, Boolean condition, that doesn't mean you should write a direct literal value true or false. Okay, even though this is a valid code, because if requires a Boolean, so that doesn't mean you should write a literal Boolean value, is what I'm saying. You have to rely on operators that generate Boolean output. Okay, you have to rely on operators that generate Boolean operators. Okay, so these are the operators that generate Boolean output, don't they?
I am offline.
All right, so this is wrong. It will always be true. It will always be true. It will be printed all the time. So when you're using the if condition, don't hard code any values like this. Okay, never write a literal Boolean value. Instead, rely on a relational or equality or conditional logical operators that generate different output. Okay. A greater than B. What is the output of A greater than B?
False.
False. It's a Boolean.
Mhm.
What's the error here?
This is just a variable B.
It's not Boolean.
B is not a Boolean.
Mm-hmm.
Okay, remember, this expression should always be a Boolean. Okay, if condition is usually true or false. Okay, control flows are usually true or false. User ID password matches, true or false. Option is 1, true. Option is 2, false. Option is 3, true. Enough balance or not? Is balance greater than withdraw amount? True or false? The conditions are always true or false. Remember that. Condition, anytime you hear the term conditions or criteria, what they're expecting you to have a value that will generate true or false. Okay, is user ID and password equal? True or false? Did they choose the right option? True or false? Do they have enough balance? True or false? Conditions are based on Boolean, true or false. Do not write condition literally like this. If true, if false. If you write like this, your program is hardwired to do the same thing or every time. It will always be true or it will always be false. This is not the right way to use the control flows. Control flows should be used with other expression, other operators that can generate a Boolean value. Okay. Now, can I write if A? Anusha.
No.
Anusha. Bhatta.
Sir?
Can I write if A?
No, we cannot write.
Because
It is uh, actually it is like just A is not a comparing value, it's just the type, data type, data.
it's an integer.
It's integer.
And what does if require?
Comparison, Boolean,
What is the input that if condition requires?
Boolean.
Boolean.
It requires a Boolean. Is A a Boolean?
No.
No. Suresha?
Yes, sir.
If C.
No, sir. Yes, if C there is, but that one is the value, so no. The
No.
program values.
Okay, here is two things, right? Programming wise, when you write the code, will this generate any error? If C.
No, no error, but
No error.
No logic.
but there is no
Right.
value by writing that true.
Very good. So there is no error, yes, because C is a Boolean variable. Okay, there is no error, but logically it has fault. It will always be true because C is true. Okay, this is perfectly fine. Your program doesn't complain. Okay, but logically it's not a sound program because the value will always be true. Okay, A on the other hand, not allowed because A is a integer data type.
Integer.
Okay, and if requires Boolean. Dheeraj,
Yes,
is
sir.
this okay?
If C and D. I think you can write that, but yeah, you can write that.
Okay. Shabani,
Yes, sir.
why is this allowed? If yes, why?
Can I answer?
It's not a comparison here. Like, we need to have like some output. I mean, C is a Boolean, D is a Boolean, but it does not make sense. It doesn't make a condition like that.
So what do you say? Will this be allowed without any errors or not?
Yeah, we're not gonna have an error. It's like the first time when we could see, we're not gonna get the error, but it does not make sense for the code in fact.
Okay, just say yes or no first. Is this line logic? Is this line programming wise? Is it correct? Will this give any errors or not?
No,
No errors. So I'm asking, tell me why it don't give any errors.
because the if requires a Boolean data type, and both C and D are Boolean. That's why we're not gonna see any error.
So, okay. Does anyone else want to try why this is okay?
Yeah, C is true, true, and false is true. So if true, so it's going to end up at the line 12.
Right.
It's always true.
Now, first thing you need to remember is logical operator requires a Boolean and a Boolean. So is C and D a Boolean?
Yes.
What is the output of logical operator?
False.
No, generally I'm saying.
Oh.
Boolean.
Boolean.
It's a Boolean. Output of the logical operator is a Boolean. C and D. C is true, D is false. What is true and false?
False.
The value false is again a Boolean, isn't it?
Yes.
Overall, this expression resolves. Okay, and here's the point. When I say expression, I'm talking about the operators. Okay, this is an expression. Okay, so when I say output, what you guys are supposed to tell me is you have to deduce what will happen when this expression is resolved. What is the final value you get out of this expression? That's what I want to hear.
Boolean value.
The final output of this expression is Boolean. And what does if require?
Boolean.
A Boolean. So this is a perfectly valid statement. No errors. Why is this error?
Oh, it's a Boolean and
Because
integer.
it says integer.
Logical operator requires what? Left hand side, right hand side?
Boolean.
It requires Boolean. Left hand side, right hand side. This is Boolean. This is not. That's why they complain. Rajan?
Yes,
Is
sir.
this a valid statement?
Excuse me, sir. Can you repeat one more time, please?
Is this line valid?
No.
Why?
I think it's not combining the value with it.
Manish?
Yes, it's valid because A is smaller than B.
Right. Now, this is why I was stressing yesterday, guys, in our previous class. When you guys are using operators, there are two things you need to focus on. First, are the input valid? And second, what is the output of that statement, of that operator? The rules for operators are what is the input you need here? On left hand side, right hand side?
Any data type.
Any data type.
Any data type on left hand side and right hand side. What is the second rule with respect to input?
Boolean.
Boolean.
Input. I'm saying input. So anything meaning, any data type meaning, can I write like this?
No.
Same data
What
type
is
it
the
should
second
be.
rule on the input?
Both should be
Same
same
data
data type. String, string.
Same data type.
Same data
Same
type.
data type. You can compare a number with a number or a string with a string. So the two rules are for equality operator is any data type is fine as long as they are of the same type. Now the output is
Boolean.
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 remember these points. How about this? Relational operators.
Integer or decimals.
Numbers.
Same data type. Output is
Boolean.
Boolean.
for logical operator. What's the input?
Boolean. And output is Boolean type.
This one doesn't matter, same data type or not, because only thing allowed is Boolean anyway. On left hand side, right hand side, you need a Boolean. Output is Boolean. Now the if, what is the input for if?
Relational and logical.
What do you need here? What is the input that the if
Condition. We need a condition.
And the data type is
Boolean.
Boolean.
okay. Now this is what you guys need to look at. If requires a Boolean and these operator output Boolean. So the output of relational operators, logical operators, equalitative operators becomes the input for if. The output from these operators will become the input for this one. Why is this okay?
It's right.
So,
The
Boolean.
output of this is
Boolean.
Boolean.
the Boolean. And we wrote this as the input to if, isn't it?
Yeah.
So that's what you're doing. The output of these operators feeds into the if condition here. Okay, whatever output this generate, it is fed into input for if. That's what we are doing here. Does everyone follow that?
Yes.
Is this okay?
Yes.
Yes.
First, look at the operator. For the operator equal, what is the first rule for input?
Same data type.
Any data type. A and B can be any data type.
Any
What's
data
the
type.
second rule?
This should be of same type.
Same data type. A and B. Are they same data type?
Yes, integer.
Yes.
What is the output of this expression?
Boolean.
It's a Boolean. So this will either resolve to true or
Or
false.
false.
In another word, isn't that an input to the if loop here?
Yes.
Okay. So what you technically have to see is, first of all, what expression you have. Make sure this is valid. Okay, check the left hand side, right hand side, check everything, and then identify what will be the output of this expression. Okay, output of this expression is a Boolean, and that's what if condition requires. It requires a Boolean. So basically, output of your operators is fed into the input of if loop. Okay, output of one expression is fed into input of the if condition. Okay, you are basically setting a pipeline here. Whatever comes out of the first pipe becomes the input for the second pipe, isn't it?
Yes.
Is this valid?
No.
No, no.
Why?
Just
Because
assigning.
it's assigning.
The assignment.
Mm-hmm.
So in this case, A equals B. What is the output of A equals B?
20.
20 value of B.
It's a value. It's not a
Value
Boolean.
of B. 20 is
Mm-hmm.
the output. So 20 is what data type?
Integer.
Integer.
Integer. And what does if requires?
Boolean.
Boolean.
Boolean. Okay. This will resolve into something like this. If A equals B, like this, which is not okay. If cannot have integers, it requires Boolean, because this is an assignment operator.
That's right.
Okay.
Mm-hmm.
Whereas this A equals B, what is the expression output?
Boolean.
And is this valid?
Yes.
Yes, sir.
If requires Boolean, and this expression output is Boolean. So finally, this is what you deduce. Rajan,
Yes, sir.
is this a valid statement?
Is greater than B and is yes, sir. Yeah.
Yes. So in this statement, how do you resolve this first?
A is greater than B and A is smaller than B.
Very good. So what will be this resolving to?
Boolean, I think.
No, with A is 10 and B is 20.
Oh, okay. Hold on. A is there is false, I think.
Then which operator do you resolve next? Or less than?
It's a true. So
And
it's
what happens in the next step?
a finally true. Yeah.
So this statement finally resolved into this line, isn't it?
Yes, sir.
And the final output was a Boolean.
Yeah.
So this is a valid statement. If requires a Boolean and what you gave is a Boolean. Okay. This is valid. Salik, is this valid?
Line number 13.
Yes, line number 13. Yeah.
It's not valid, I think.
Very good. Why is it not valid?
If a statement always takes a Boolean values, but it is a string one.
Perfect. Perfect. Rupesh?
Yes.
Is this valid?
Yes.
Very good. Why is it valid?
Like yes and yes to our Boolean value. And
Yes.
it's true. And equals to.
So why is this valid?
Is if a statement and is equal s is equal to yes to and it's true.
Sabuj, you want to rephrase that properly? Sabuj?
The S and S2 variables, it consists of data type string. So it's not valid.
It's not valid. Okay. Sabin?
Yeah, it is valid.
It is valid. Why?
The input can be of any data type, and the both are the same data type. That's string.
Very good. And
S
what's
S2.
the... Okay, so first part is correct.
Mhm. And its output is false.
Very good. Okay, so Sabuj, Rupesh, the reason it is valid is not because it is string, it is Boolean, nothing. First is you have a equality operator here. Left hand side, right hand side, both are string. First check is done, any data type. The second check is, are they of same kind? S is a string, S2 is a string. So it's valid input. What is the output of this?
False.
False, which is a Boolean. And what does if requires?
Boolean.
A Boolean. When all checks are done, now that you can confidently say this is a valid statement. Can you say S equals A?
No.
This is different data type, this is different. You cannot. This is okay. Same data type, B and A. The output of this is
False.
Boolean.
a Boolean, which is what if loop requires. Okay. Now this is a exercise on how to use if loop. Okay. You should never write any fixed value. Now here, Eclipse is trying to warn you. Why does it say dead code? What does dead code mean?
Not moving further.
It will never be executed. Why will it be never executed?
If is always true.
It's always true. This part is always true. Since this is always true, you'll end up in this block only. You'll never go to else block. So technically, it's still a valid program. There is no error. If you see, there is no red marks. Okay, these are errors. These are errors. And what do we call this yellow line? It's called warning. It's just a warning saying this, whatever you're writing here, this doesn't make sense. Why doesn't it make sense? Because this is always true. If this is always true, you will never go to this section at all. So this is technically a dead code. Dead code because it will never be part of any execution. You will always go to the true condition and this will be executed. Technically, this is still allowed, but logic wise, it doesn't make any sense. Okay, that's why Eclipse is trying to warn you. This is a dead code. It's of no use. Okay.
This conference will now be recorded.
Okay, let's assume a bank account program has a balance. Okay. And it has customer PIN. Okay. These are the attributes a bank account has. Okay, bank account has a balance and it has customer PIN. What are the methods that a bank account might have? Okay, what is the first thing you do with an account?
Deposit or withdraw.
Okay.
Balance.
Get balance.
Now, get balance, do you have to enter any amount number or anything?
No.
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 No input. No input. For withdraw, what's the input you need?
Amount.
Withdraw amount.
For deposit?
Amount.
Deposit amount.
Do you guys know what authenticate means?
Means login and password?
Right. Authenticate is where you validate if the customer is who he or she is. Okay. Basically, you confirm this is a valid transaction, this is a valid customer trying to do legal thing. Before you do anything, transfer money, anything, you want to make sure the person is not an imposter or something, and he genuinely owns this account. That's what authenticate means. Okay. Now for this, customer will enter a PIN when they're using your software. Okay. Now here, let's make use of control flows and see what you can do. Now when you're writing a program, you have to consider all these facts. Okay, what information you have in your account and what is the input that the user will pass you. So in the bank account, what is the information you have?
Balance and customer PIN.
Balance and customer PIN. In the authentication feature, what will the customer pass you?
PIN.
PIN.
Pass you the PIN. So I'm giving you the conditions. If customer's PIN matches your records, welcome them. If it doesn't match, show them a message, invalid PIN entered. So, what code would you write here?
Customer PIN equal PIN.
Select
PIN.
Yes, sir.
Okay, what condition would you write here?
If customer PIN equals PIN.
Customer PIN.
PIN equals
Customer PIN.
Then what do you do?
Then we'll execute the if statement. We show the welcome message.
Rupendra, how do you show the message invalid PIN?
Using else.
Okay, you can use else, but we haven't done else part yet. Use the if loop itself.
Not equal to?
Yes. This is how your program looks like when you write the control flows and all. Okay, you take some input from the end user, you compare with what you have, and if it matches, you do something. If it doesn't match, you do something else. Okay. Now this is the customer and this is the bank account. Okay. If I want to call the authenticate method, how do I call it?
Create reference for the class bank account.
And
BA dot authentication.
The method.
And now pass the PIN.
Now when I pass all right, Manish, when
Yes,
I
sir.
pass 111, what happens here? What happens when we call this method?
Your personal, okay.
No, basically program wise, what happens when you call a method?
So you return?
Now where do you go from here?
You go from here to the bank account.
You go to the bank account. Okay.
Yes.
So Shrestha,
Yes, sir.
what happens when you go to this line?
We go to the method that one is authenticate, and yeah, and we compare if pin is equal to customer pin, system dot print out welcome. If pin is not equal to customer pin, invalid pin.
Okay. So here, when you pass 111, where does it go? Where does this value go?
It goes. The value goes pin does not equal to customer pin.
Yeah, but this 111 is passed to which variable?
It goes to invalid pin.
Yeah,
No, I'm not saying. Yeah, this variable goes to which, this value is assigned to which variable?
Into pin.
Very good. The pin will have the value 111. Whatever value you pass here, it goes to the authenticate method, and pin variable will have the value 111. What is the value of customer pin?
123.
123. So pin has 111, customer pin has 123. So when you compare 111 equals 123, will this, what is the output of this?
False.
True.
111 equals 123. It is true or false?
Oh, that's false. It's gonna go to no.
So will welcome be printed or not?
No.
No. If this condition satisfies, the first if block will be skipped. This condition satisfies, then it will be executed. If this condition fails, it will not be executed. So the second if loop, is this condition true or false?
True.
True.
It's true. So will it print welcome or invalid pin?
Invalid pin.
What will it print?
Welcome.
First condition, welcome.
Okay, so you should use the if loop in this fashion. Okay, you're always playing with variables. There is some information that you have with you, and the other information is passed with from the user. Okay, and based on this, you write some conditions that gives your program different flows, a welcome flow, error flow, and so on. All these blocks will be executed based on which condition is satisfied, which if block is true and which is false. Based on that, your program will either print welcome or invalid. Okay. So Rohil, help me write the code for withdraw.
Okay. If balance equal to balance equal and less to withdraw.
Less than or equal.
Equal to withdraw.
Greater than or equal, or less than or equal?
It will be less than equal because balance is the amount in our bank, and withdraw is the amount which we are asking for. So
Is this how you want?
no, then it will be then we can write withdraw approved.
Okay, what do you want to write here?
Withdraw approved.
What else?
Else enter the withdraw amount again, or not enough balance.
Okay, your thought process is right. Okay. So does anyone find any fault here?
Yeah, if the withdraw amount is less than equal to balance.
Yes. So you have to do AND operator.
The logic.
So if
Balance is
balance
greater
is
than
less than what they enter, then it is approved.
balance will be
Balance
more
is
than
less than withdraw amount. So if you have $1,000 and if I give the withdraw amount as 5,000, will it print withdraw approved or not enough balance?
it will say not in balance. The balance
Not
is less than.
balance.
So should this be less than or greater than?
Greater than.
Greater than. Okay, Rohil, balance should be greater than how much you are trying to withdraw, isn't it?
True.
It should be greater than, not less than. Not enough balance. You have 100 and you're trying to withdraw, customer is trying to withdraw 123. Not enough balance. Approved. You have 100, customer is trying to withdraw 90. Okay. All right, so you see all your knowledge on how the global variable is accessed. Okay. In this method, you can access global variable, don't you?
Yes, sir.
Okay. That knowledge based on what you know about methods, what is the input to your software, what do you output? Combine that with the control flows. This is now a complete software. Okay, until now, you guys have been doing like this. Okay, in every method, you just have sits out. If it is int, return type is int, then you're saying return 1. This is how you guys have been writing code so far, because we haven't been to control flows yet, right? With the control flows, now you have a way to control your logic, to write the program, to write the actual implementation, to write the actual code. So far, you guys have been dealing with this part, variables and methods. Now, what we are doing with control flow is more about what you write inside the method. How do you make it actually work? Now your program is actually doing something. Not blindly returning true or returning 1 sys out. This is what control flow gives you. Control flow actually gives you a way to write the code, not just declare. Okay, this program is just declaring. You have variables and you have method, but does this method really do anything?
No.
No.
Nothing. This is an empty method. It has no logic. There is no working conditions. It doesn't work. It is just for namesake. So that's what control flow brings to the table. It gives you a way to write the logic, write the program, condition check, control flows. Okay. So we are going in a step now. After that, after doing the variables and method, you guys might be wondering, what do we write inside method? You write this kind of a code. Okay, remember how to use the control flow if, what it requires. Okay, it requires Boolean. So since if requires Boolean, should I write only Boolean values?
No.
You shouldn't. Okay, if I write only Boolean values, this is a problem. And Eclipse will try to warn you. Okay, this is not a good code. What will it print?
True.
Welcome.
It will print welcome. Will it print anything else?
No. It stops there. Oh.
Yeah, we have to call authenticate.
Both. Why did print welcome?
Because it's true.
A variable is true. Why did print invalid pin?
Because it was wrong. False.
Pins don't match. 1, 2, 3, 2, 3, 4. So this condition was satisfied because of this expression, not equal to, and this was always true anyway. So since this is always true, no matter you enter the correct pin or the wrong pin, it will always print welcome. Okay, correct pin, it says welcome. Wrong pin, it says welcome. So if condition requires a Boolean, that doesn't mean you have to pass a literal Boolean variable or a literal Boolean value. Don't do that. Okay, you should derive a Boolean from another expression like equals to. Take help of other operators that generates Boolean values. Equal, relational, logical. Okay, use other operators that generates Boolean output. Rely on them. Use them in your conditions. Does that make sense?
Yes, sir.
Yes, sir.
Yes, sir.
All right, so that's the only tough part. Okay, you need to understand how to use these variables, what input is required. All the other control flows that we'll learn going forward, okay, for loop, if loop, while loop, do while, they all rely on conditions. So the trick is not on how for is written, how to do for loop, while loop, but the main thing you need to focus on is how that applies in your code. Okay, how do we write this? Okay, we need to compare variables. We need to rely on equality operators, relational operators. We need to rely on logical operators that usually generates a Boolean output. Okay, all the control flows, if loop, if else, for, while, do while, switch case, they all rely on Boolean output, Boolean conditions. Okay, but that doesn't mean if you have Boolean, you can pass a Boolean variable. Yes, you can, but your logic requires a little bit more finesse. You need to rely on relational operators, equality operators that usually generate a Boolean output rather than writing like this. Okay. All right. So here we are relying on if and if condition. This could be very easily written with the if else condition. Okay. If else is more like a either or scenario. So what this means is if this condition satisfies, meaning if this gives you true, then execute the first block. If this condition is false, go to the else block. That's what it means. Okay. So if else is a either or scenario. If condition satisfies, go here. If the condition doesn't satisfies, go to the else. Okay. If I have enough money, I'll buy a car. If I don't have enough money, I will use the public transport. If I have money, buy a car, else use public transport. All the time you're making decisions like that, either or. If you have enough money, you do this, or else you do that. If you get up early, you'll go for a jogging, else you won't. All the time, based on certain condition, you can either end up in the if block, either block, or you go to the or block, else block. Either or, if else. If this satisfies, do it, else do that. That's how if else is used. Okay, but this only is suitable for two options, isn't it? Either you go do this or that. This is suitable only for two conditions, two outcomes. Okay, so what Java gives you is a multiple options as well. Okay, you can do multiple things. If A equals 1, show the message, enter withdraw amount. Okay, so I'm asking customer to enter option 1, 2, or 3. Okay, if you want to withdraw, enter 1. If you want to deposit, enter 2. If you want to change your PIN, enter 3. Okay, now your program has multiple options now. It's not an either or scenario, is it? Take this. In this case, you have multiple options, right? 1 for withdraw, 2 for deposit, 3 for balance check. Does this fit into your either or scenario?
No.
No. So if else is not suitable for this. If else is only for either or, two options. If you have more than two options, then you have to go with if else. Okay, so here is what we're doing. I call the method options and the customer enters 1. Okay, so 1 goes to which variable? A. So is A equal to 1? Is it true?
Yes.
Yes. So it enters the first block and prints enter withdraw amount. So this is the beauty of if else if. Okay, just like if else, at any given point you can either be part of the first or the second, isn't it? Can you print welcome and invalid pin both at the same time? Has any
No.
software done that?
No, we cannot.
So either it will print welcome or invalid pin.
Mm-hmm.
Either it will welcome to your website or it will say your login
Invalid
has failed. Don't say both. Similarly, even in this case, once you enter one of the block, the others are skipped. Remember that. If any of these conditions satisfies, the next block will not be executed. It guarantees only one block at a time. All right, Salik, what will it print?
Yes, sir. It will gonna print high and inter withdraw amount.
Go from the top till the end of the method and
Till
guess
the,
the output.
oh, sorry, I forgot the last one. And then it high and it print the inter withdraw amount, and then at last it's gonna print buy.
Very good.
Yes, sir.
High, the very first line, enter withdraw amount, the first block. As you see, when this condition satisfies, it did skip all the other checks. It did not go to any other block. As soon as this ends, the final line is printed, buy. Rupesh, what will it print?
Hi. Enter new pin. Buy.
That's it. Did everyone understand this? Any question in this?
No.
No, sir.
Okay. All right. So if else or if else if this is what you do. You write if you want certain actions to be done based on a condition. If condition satisfies, I want to do bunch of things. That's when you choose if. If you have two options, okay, like if the condition satisfies, you want to do option 1. If the condition doesn't satisfy, you want to do option 2. Then you go with if else. If you have more than 2 options, you go with if, else if, as many else if as you want, and finally else, default option. Okay, when you're writing a code, if you want certain code to be executed based on a condition, you just go with if. If your program requires either or scenario, okay, if condition satisfies, do that, or else do other thing. Okay, think about else like a default condition. Default condition is if nothing satisfies, you go there. Look at this scenario. what if I enter 5?
Oh, invalid input.
Does any of the condition match?
No.
No. So what is else block? Isn't it a default block?
Yes.
6, 4, 5, 8.
Mm.
Any option you enter, it will always go to the else block if none of these satisfies. So else is more like a default block. If none of the conditions satisfies, you end up here. Okay, this is like a fail safe. Okay, you go to ATM software or you go to any other software that requires a default block, default message, you will see that written in an else block. Okay, any input you give, if none of the conditions satisfies, it goes to your default block. It's an optional thing, really. Okay, it's an optional thing. So what will it print this time?
Hi. Oh, and bye. Hi and bye.
That's it. No condition satisfied, so it prints the first line and the last line. None of the if block were executed. Okay, so think about else block as a default block. So you did not tell the customer what was wrong. You just said bye, you're done. Okay, so else block makes sense when you want a default message. Invalid output. Website is down for some maintenance. Please try again after some time. Our lines are busy. Please call us after some time. These are all default blocks. If nothing can be done, this is what you see as a default message. Okay. Right. So one final thing you need to remember is the block. Block is an optional thing. Okay. Now, typically what we do, all this block, all the conditions, don't they have just one line to execute? Right? The if block, a equals 1. How many lines do we have in this block?
1.
How about else if?
1.
Okay.
2 lines.
If you have just one line of, see, block is meant to be used when you have more than one line. Block is like a group of lines. Okay. That's what block represents. Block is meant for grouping multiple lines together. Okay. If you want to do multiple things in this block, you use the curly bracket. Since there is only one line, it's optional. You don't need that. This program will still work fine without the blocks because every block has just one line. If you have more than one line, then you need to put the block, the curly bracket. Is that clear?
No,
Okay.
that doesn't. I don't understand that.
Invalid input. It's still, the output is still the same. Okay. Output is still the same, no problem. What you need to pay attention is, if you have more than one line, you have to put that in a block. Okay, let's see. Here I say invalid input, and okay, this is my message. Now, logically speaking, When do you want to print this line?
When option 1, 2, 3 doesn't work.
If the option 1, 2, 3 doesn't work, when do you want to print this message?
The same time and the option 1, 2, 3 doesn't work.
Doesn't work. So there are 2 lines you want to print as part of the final block, final condition, isn't it?
Mm-hmm.
Now, if you don't put a block around this, what will happen? Okay, if you put a block, it makes sense. Okay, if you put a block around the else block, now you're grouping together. So you have more than one line as part of this condition, isn't it? What we will see is what happens if you don't have this. Okay, if no block curly bracket is written, that means this condition, and this condition has only one line. Remember that. If no curly bracket, meaning there is only one line after that condition. So when I enter 3, what will it print?
Enter new pin. Hi, or enter new pin by.
Hi, enter new pin and
Bye. Oh, it's not gonna print by. It's gonna. Yeah, it's gonna print both lines.
it is still printing this line. Please enter. Why is it printing this line? So for the else block, how many lines of code do you have?
2.
2. But did you group them together with a curly bracket?
No, I didn't. We didn't.
So if there is no curly bracket, which lines among these 3 belong to else?
All 3.
All 3.
Okay, just the first line.
Was the
Only
first
the
line or
first
all
line.
3?
If you do not have curly bracket, okay, this is what it does. If you have a curly bracket, what it means is after else, immediately, if you find a curly bracket, meaning all the lines underneath that curly bracket belongs to else. Okay, that's what it means. But if you don't have this, what Java assumes is only the first line immediately followed by else belongs to it.
Oh,
Only these 2 are together. That's what it feels.
okay, understand that.
So if you have more than one line that you want to make it part of else, what do?
Brackets.
Put the bracket and group them. Okay, you have to group them. So what is curly bracket? What does block means technically?
Grouping
We are
multiple
group
lines
of
together.
more than one lines. Okay, group of more than one lines. That's what block means. Okay, so as part of this condition or this flow, if you have more than one line, you have to group them together. If there is no curly bracket written, which line is part of else? Is it the blank line, invalid input, or both?
Only one. Input. Invalid input.
Invalid input. Okay, this is the only line that is part of else. Okay. What will it print now?
Hi, enter new pin and bye.
Okay, that's what the curly bracket means. If you have more than one line that belong to only one section, group them. If you do not group them, you'll get an error.
No.
Okay. Now, it's a very usual habit to end all the line with semicolons for us, right? You declare a variable, semicolon. You call a method, semicolon, right? This is what you guys need to remember. Do not end if condition with a semicolon. Never ever do that. A semicolon followed by any control flow means empty line. Empty statement is what it is called. Empty statement. Okay. So let me give you an example. Okay, this is a common habit. We end every line, declaration, method call, we end everything with semicolon. Do not do this. Let's see. What will it print?
It will print withdraw. Hi,
Hi.
withdraw. Oh,
What will it print?
just hi.
It will print the high and the withdraw.
Still hi and withdraw.
So this is what it does. If you have a semicolon, it technically operates like this. Semicolon next to the control flow, if, for, while is a empty block. Semicolon is equal to do nothing block, empty block. Okay, that's what you need to remember. Semicolon is equal to empty block. Now, technically, is this line part of the if block?
Yes.
Not logically.
No.
I'm saying
No,
programming
no,
wise.
no. It doesn't. Yeah, no. It's not.
Is there any sits out inside? See, only these lines belong to this condition, isn't it?
Yes.
Okay. So this line is outside the block, right?
Yes.
It doesn't even belong to the if condition at all. It is just like your by statement. The by line, the sits out by, was just outside your if else block. It was not in part of any of these conditions. It was just any other line. So when you do like this, okay, if you write a program like this, ending the if statement with a semicolon, Java will assume this is what you meant. Okay, this is what Java will assume if you write a code like this. If you write semicolon, it means if the condition satisfied, what will it do?
Nothing.
Will do nothing. So when you're done with this condition, don't you move on with the next line and the next line and the next line?
Yes.
So this is just any other line outside the if block, isn't it? This doesn't belong to your condition at all. It is outside your if block. So when you're done with this condition, no matter this satisfies or not, even if it doesn't satisfy, you will move on with the next line printing withdraw. Okay, so remember, do not end your control flow statements. If, for loop, while loop, any of the control flow that you learn, do not end these with a semicolon. It will entirely change your meaning. If you write a semicolon here, this means do nothing, empty statement, empty block. Okay, do not do that. That's why no matter what you give, okay, no matter what you give here, you give 5, 2, 3, no matter what you do, it will always print withdraw. Okay, because this, when you look at the code, it looks like maybe it is part of if, but technically it is not. This is what Java will interpret what you really meant. Semicolon equals to empty block. Remember this. Semicolon next to control flows equals to empty block. Do nothing. Any line that proceeds after that is a usual line. Okay. Now, one last thing in the if-else block. Else should always be part of if. Now think about this for a moment. When you're talking to someone, do you start your sentence something like, or we will meet there, we'll meet in a shopping mall? Is that how you phrase your sentence? Or do you say either we'll meet at our house or at a shopping mall? That's the correct line. Or the correct line is, or we will meet in shopping mall. Do you begin your sentence with a or ever?
No.
No.
You don't. Your sentence always begins either we will do this or we will do that. Either I can come to your house or we can meet somewhere else. That's how you phrase your sentence all the time. Your sentence always begins with either do something or we can do something else. That's how your statement begins. No one starts their sentence with or. Or is always followed by either. Okay. Similarly, in Java program, you cannot write a statement starting with else. You always have to start with a if. If this, else that. Either this or that. In Java, you cannot begin your statement with else, just like you don't do that in real world. Okay, so your statement cannot begin with a else. You cannot begin with else anytime. It should always begin with this is the right statement. It always should begin with if. If this condition is true, do something. Else if this condition is true, do something. Finally, nothing matches, do that. You cannot begin anything without an if. Okay? Always begin your logic with a if statement. After if, you can write anything. After if, you can have else if, or you can just have else. Okay? Either way, you cannot begin with else anywhere. You have to always begin with if condition. Either this or that or that or other thing. So here, what happens if I put a semicolon here?
It will be empty block.
It's an empty block. Now, when you write if-else if condition, one thing to remember is they should be written in a continuous sequence. Okay, like this. Do you see this? Don't they immediately follow if block? Immediately we have else if. Else if, immediately we have else. So aren't they a continuous sequence? Yes or no? Okay, 5 more minutes and we won't go with the remaining control flows. Okay, just keep up with for another 5 minutes. If, else if, they're all part of a chain. If you introduce any other line, you break the chain. This is an error. Why?
Breaking the
It's not a sequence.
sequence.
Okay, you're breaking this if else if chain. The if condition ends on line number 9. This is where it ends, the if statement. Else if should be immediately followed by the ending line. If you add any code in between, it breaks the chain. Okay, if it breaks chain, you start all over again. Okay, you're starting all over again here. And as per rule, what is the first thing you write?
If
If. This is fine. This is a separate sequence, some print statement, another separate sequence. This is fine, but this is not. This is the first if block, and this is another if block, which doesn't begin with if. Okay, and that's why the message. So you cannot introduce, if you want all these part of the same chain, do not introduce any line in between. Do not do this, or else you'll have error. This is now a continuous chain. If block, as soon as it ends, begin the else if. As soon as this ends, begin the else. If you add any line in between, you break the chain, and this will complain, saying this block doesn't have a if. Delete else, and you'll be fine. It's giving you a suggestion. Okay. So with that in mind, what happens if I give a semicolon here?
Empty block.
Why do we have this error? If I put semicolon, I'm getting an error on line 9.
if
It starts
statement,
with else.
we need to start from there. We need to start from if.
Right.
New block will start.
So semicolon means empty block, right?
Right.
Empty block. If statement ends in line number 9, else if begins here. What do we have in the middle?
A print statement that should not be there.
It breaks the chain, isn't it?
Yes.
That's why the error. You might be wondering why I'm getting error here when I put a semicolon on line 7. Okay, if you give a semicolon here, error pops up on line number 9. The reason is when you give semicolon here, this will behave like an empty block. So when your if block ends and else if begins, if you have any line in between, you're breaking the chain. If you break that chain, it will complain. It will say there is no if block for the else if. Delete this. Okay, so remember, do not end any control flows with a semicolon. It applies here as well. What happens if I put a semicolon here? Where do you get the error?
Line number 11.
On else statement.
Line number 11 is where you get the error, because this semicolon behaves as a default block, sorry, empty block. Now followed by this else if, and before the beginning of this else if, did we break the chain?
Yes.
And that's why the error. Okay, since we broke the chain, that's why you're getting the error. Semicolon, you have an error. If you put semicolon, you get empty block. The moment you have empty block, before this block ends, sorry, after this block ends and the next block begins, you break the chain and it complains. Now, no errors. Else if has only one line, and immediately after that we have else. You put anything in between, okay, not just sys out. If I do int a equals 10, did you break the chain?
Yes.
What if I do a equals 20? Still broke the chain.
Okay. Yeah.
Any line you put between the else if and else, between the if loop and else if, anything you put in between, you break the chain. Okay, it should be a continuous block. One line block. If you don't have curly bracket, what does that mean? It's a single line block, just single line. If you have multiple lines, you need to group them. All right. Okay, so what I want you guys to practice is try different variations of condition. Okay, try relational operator, logical operators, equality operators. Use various combination to make your program utilize the if loop. Okay, and come up with any valid examples like this: bank account, Facebook website where you log in, okay, email account, anything you can use to practice the conditional if control flow.
So can I share my screen? I made a small software.
Which one? Can you repeat that?
Can I share my screen? Me and Varda were working on a small software. It has the if else statement.
Sure.
And the operators.
This conference will now be recorded.
Right, so good thing Rohil brought up this point. Now sometimes if you have integer to return, be very careful when you're using conditional control flows. Okay, this might be happening for each one of you. Now, why do we have this error even though we have a return statement? If the return type is int, you have to return something. Aren't we returning 100?
Yes.
But why the error? This method must return a result int is what it is complaining. And we are returning int. So why the error?
It should be outside the if statement.
Because it's the conditional, it's not always returning. It's only returning 100. If a is equal to 1, other cases it's not returning, so it's error.
Yes. So this method will return integer only when input passed is 1. If I pass 2, okay, if I pass value 2 to this method, will this method return me anything?
No.
No.
Don't. If I pass 2, will this condition satisfy? If I pass value 2, will this condition satisfy?
No.
You don't. So if this condition fails, did you return anything?
No.
That's what it's complaining. So if you have control flow, like if, else, if, all that, your program should be designed to return any value in any flow. Okay. If I write return here, this will satisfy. If I pass value 2, the value 2 goes all the way to option method and variable A. Okay, variable A now has the value 2. Okay. If A equals 1, is this condition satisfied?
No.
You don't. So will it return 100?
No.
No.
So if this condition fails, don't you move on with the next line of code?
Mm-hmm.
Yes.
In this case, it will return -1.
Mm-hmm.
If I pass 1, what will it return?
100.
This condition is satisfied and you return 100. Okay, this is what you need to remember. When you're writing the program, anytime you encounter return, it won't process anything further. It will just return back to the caller. Okay, so if you're using if, else, if, any control flows for that matter, you should make sure your program is capable of returning something from every possible flow. What is the problem in this code?
Still the same problem?
Still the same problem. If option is passed as 1, you return something. If I pass option as 2, you still return something. If I pass as 3, you still manage to return something. What if I pass anything other than 1, 2, 3? Is your program capable of returning anything if the A value is 1, 2, 3?
No.
It's not. And that's what it's complaining. Because program, the Eclipse is predicting if the value is integer, what kind of value can you pass here? What is the range of int variable? Integer has a range of 2 billion, isn't it?
Yes.
Yes.
The customer can pass any number up to 2 billion. So is your program able to handle all that?
No.
No.
No. So that's why we rely on else block as a default block. So you have something to return if the options exceed. Now it doesn't complain because we know that program knows that if the input is integer, user can pass any value up to 2 billion. So do you really want to write 2 billion conditions like this? If A equals 1, A equals 2, all the way till 2 billion?
No.
It's physically not possible, right? It might take 10 years just to write up to 2 billion, maybe more than that.
Mm-hmm.
So what we do is we write an else block, and if none of the conditions satisfies, we do have an else block where we can return you something as a default. But if you don't have else block, the default block, it complains. It says your program is designed to return if the input is either 1 or 2 or 3. What happens if the user sends you anything between 4 and 2 billion? Your program is not equipped to return anything. Your program will not return anything if the input is greater than 3 or less than 2 billion. And Eclipse will predict that. Okay, and because you need to understand, the users are unpredictable. It might be a mistake. Okay, when you go to ATM software, they ask you to enter option 1, 2, 3, and by mistake you enter 1 twice. It's a human error, typo. You hit that 2 times, 1, 1. So now, if your program is not designed to handle such a scenario, it will cause errors like this. So you should predict what they can send, what they won't. Okay, and your program should be ready to return in any given situation. Okay, you can either write just return, or you can write in a else block. If any condition satisfies, I will return these selective values. If none of the conditions satisfies, I have a final default value that I'm sending to the user, -1. Okay, remember that. Use return when you're using return statement. You should be able to return from any of these blocks. Okay.